Hey folks, so myself I'm Praveen. So I come with an industry experience of 8 years, and the last 5 years it's been into data now. I've worked with quite a bit of common data tech stacks now. Like I was a data backend engineer prior. The transition sort of happened organically. Like yeah, that's pretty much about.
Hi everyone. I'm Tanay, and I have worked with data for a couple of years, but right now I'm not working with data back in software engineering. But I would like to call myself as an enthusiast, wherein I try a polyglot approach, wherein I try to switch the technologies and the tech stack that I work with as I switch to a different project. Apart from that, in my free time also I do some weird coding, like I sometimes sit and make games or things like that. Going on to today's topic, we are going to play around with movie data transformation. So the main thing we wanted to do is to introduce DBT as a tool for data engineers. Taking some data, like let's say catalog from some online website like Flipkart or something, and trying to do that would be kind of boring. So something kind of interesting. So I'll take a poll. How many of you don't like watching movies? Anyone? No, I guess people like watching movies. So something that most of the people like is we chose movie data.
So also this talk is primarily about DBT and how it works. We'll also be slightly touching Snowflake, like which might be like until you know like SQL that's enough. But like other things about Snowflake is like totally out of the scope for this discussion. So yeah, let's get started. So yeah, in today's data-driven world, if you see organizations are collecting information at an unprecedented rate. So these informations that they collect has the potential to revolutionize every aspect of our lives. Let's say from healthcare, finance, marketing, travel. Like it can improve all our aspects of our life. But again, it's just raw data. Raw data is just potential. In the end, it's data engineers whose role is to actually transform these raw data into more usable form, so that towards the end consumers like data analysts or data scientists or some sort of dashboard through which it can actually be made sense of. So what is data engineering? So again, data engineering is a discipline of building and provisioning systems that will collect, process, and then manage the data. Again, it's the role of data engineers to actually build data pipelines where data will be transformed from raw data into usable format. When we talk about data engineering is a very broad field, and it's a multi-stage process, I would say. Each and every diagram in this, every box in this picture itself is an own process, I would say. Let's say data source the entire ingestion would happen. The ingestion might happen from various places. It might be from a structured database, unstructured database, social media feeds, IoT sensors. It can be from various places. So these would be your primary sources from where you will sort of ingest our data. Once the data is in, what the next thing that we'll do is we need to make sure that the data is in some place. So that is where data warehouse comes in. Deciding, I would say instead of here it's specifically data warehouse, but I want to call it as a data store. The data store we can decide on the data store on various different reasons. One is the volume of the data, the velocity of the data. Depending on that, we can decide what type of data store that we need for our solution. So again, coming to the next is the transform part. Transform part, currently in data engineering world, there are two ways in which you can actually do. So one is there is this ETL analogy which has been there for a very long time. It's the traditional approach where you sort of extract from there, transform it, and then load. In ETL, it's more around once you extract the data, you would sort of transform before putting it to somewhere. And ELT is something new where once you extracted, you load the data into a data warehouse and leverage the power of data warehouse to actually perform any transformation. just to give some example of what an ETL tool and ELT tool I would say is ETL tool, something like an Informatica or Spark is ETL, where you sort of load entire data in your memory, do the processing, and then sort of get the the data out of it. But whereas for a data warehouse, I would say something like again DBT is a ELT tool, and there's an enterprise ingestion tool called 5ton, which sort of again performs the transform. It loads the data and then it sort of performs the transformation. So the next is it's the other one. I would say that dotted box is the end consumers always. BA tools is more around the visualization tool, like with which we can make sense out of our data. And AML models is the one, like it's the primary consumer for like the data generated by data engineers these days. So where does DBT fit in? So as I said, DBT is a transformation tool. Like we'll be using this to actually perform transformation on a warehouse. So what is DBT then? DBT is called a data build tool, and this is a powerful open source. Yeah.
So, ETL is when you know ELT, it's like you already loaded the data into the data. Then how the transformation will happen? Like it will again go and take the data from.
We will show that. We'll show how the data is once it comes, and we'll show how the transformation is done. But the idea is to take raw data as it is. But how it will happen, we'll show it in subsequently. Just wait for the other. Yeah.
So as I said, DBT is a powerful open source tool. Like it's primarily built for transformation on data warehouses, and DBT is the reason why it is so powerful. Is like it fundamentally it uses SQL as its language to perform this transformation. Since it's SQL, like it's very user friendly for both data engineers and data scientists as well. Also, one other reason why it's more powerful is DBT sort of uses a Jinja 2 templating. Jinja 2 templating is a very powerful templating language with which you can sort of on runtime you can like inject runtime variables which make the code more modular. So as of now, we have covered what is data engineering, and what DBT does. So yeah, we'll go ahead with DBT. So now what we'll do is like instead of just like talking about it, let's actually deep dive into the code and see some interesting things.
First, I will show this. Cool. Honestly, I just want to make this as interactive as possible. So till now, any questions apart from when transformation happens? Any other questions? Anyone? You can't hear us? Can you just sit a little in front, a little better? You can hear. And you can't hear? You can hear, right? I think it's only that patch where AC is there. Okay. Cool. Mike will create an echo. Cool. So let's make it as interactive as possible. Again, I always say Murphy's law applies. So we are going to do a lot of live demo over here. So if things are supposed to go wrong, they will go wrong. Okay, so I'm just making a disclaimer right at the beginning. So we'll throw a problem and we'll try to solve it using DBT. The first problem is we have a data a set. We have ingested a set of a data set which has a set of movies. There are many movies, but the thing about movies is they have different properties. One of them is the movies are in certain languages, right? Like they can be in English, French, whatever. Now for the movies, the languages there are codes like EN for English, F for France, French, and so on, FA for Farsi, whatever. So this is available to us as a CSV file in our code, and we want it to be. We don't want to always go into Snowflake, create a table, and modify that. What we want is we want that CSV, that table in Snowflake, to be managed to the CSV file within our version control, within our repository local. So if we change anything within that CSV file, it should reflect in the table in Snowflake. Right, so let's try to do that first. So this is Snowflake dashboard. I'll just not go into this as of now. First I'll show you the directory structure of this. Is this visible or is this too big, too small? Just reduce the zoom level. Just let me know if this is fine. Is this fine font? Is this visible or bigger? Make it 150. Is this better? Cool. So we'll first show you the directory structure. Just look at this, consider this to be a project directory, ignore everything outside. This is our DBT repository. So what is happening here is there are a bunch of things. The very first thing is project, so I'll just close all tabs over here. So first is your project, so this defines all the metadata of your project. What is your project name? What profile you're using? I'll again show you where the profile comes in. It's from profiles. The model paths, analysis paths. I'll tell you what is models. I'll tell you what is test, what is seed. Seed is what the problem we have got right now, and we'll be solving that. Again, don't be overwhelmed with this. The other thing is profiles. Now I won't be opening this because this is my database username password, so I'll just open this and I'll show you how it looks. So there's user, there's password. So this is basically used to connect to Snowflake, and I showed you.
So in our use case, it is Snowflake, but it can be of any data warehouse from, say, it can be BigQuery or Redshift, it can be anything. So whatever maybe your cloud system, like you will have the credentials for that stored in your profiles.yaml, so that DBT in runtime it can sort of connect with your warehouse and then make the transformation there.
So I showed you profile in DBT project. That profile is being used from here. So that's DBT intro. That's the profile. Okay, that's it about this. Before going through all the other directories, I'll just give you a very high level. I will not open it. I'll just give you a very high level. Models. Models is like your SRC. If you come from a Java or JavaScript, that kind of a backend kind of thing, then your SRC is usually your models. Test is your test directory. Macros is where you put your reusable code. They are like functions but not functions. They are macros obviously. So this is like your lib where your reusable code goes. And seeds. Seeds is what we'll be doing first. We'll be checking how seeds work. I'll first show seeds directly. So everything we run in DBT runs from the CLI. Anyone has any questions around this? Feel free to ask anything. Huh? Yeah. So for seed, the problem that we were talking about, right? Yeah. Yeah. Yeah, nice question. So he's asking the structure that I showed, the directory structure, is it the thing that DBT is doing, or we have chosen it? It's created by DBT. It's when you do a DBT project in it, it creates a directory for you and with all the contents of it.
The good thing with this project structure is like you can sort of make your data engineering project cycle very similar to a software engineering cycle. You can sort of unit test your code. You can still have CI/CD in it. It's very similar to what you do in software engineering. Like at least the DBT project structure sort of provides that interface to this.
So back to this, I showed you this table which I want to be created in my Snowflake, and I set it as a CSV file. So I'll just open seeds, and there's this language.csv. So this file has code, language English, and this. So this exactly represents the table that I showed in Snowflake. So I want this to be created in Snowflake. It's currently not created. So what I will do is I will say dbt seed. So it's like running, let's say, something build, something test, right? Whatever your tool is, like Java, it's Java C or something like that, right? So for DBT we run dbt seed. So everything will be doing through command line over here. So I'll run DBT seed, and this will connect to the Snowflake, and it will run whatever is there. So what DBT seed does is it basically just takes this CSV file. If it's already there, it will update it. If it's not there, it will create it. So let's look at our structure. So this is our database. These are the schemas in the database. In the landing, there should be a new table now called language. This is what we are trying to create. It has number of rows 85. Let's check if this also has 85. It has 85. 86 because there's a header. Okay. So let's select from and I ran this, and this is the exact table that we were expecting we got over here. So far, any questions? Yeah.
So the CSV that you have shown, right, it's a comma affected or it is very key. Suppose there are some unexpected data or unexpected commas, and there may be a chance you might be getting the tabs of comma and CSV unexpected. So in that case, can we give a separator or enumerate the CSV and repeat to the automatic emails there is some missing data?
I would suggest not to use DBT seed for that. So data cleaning is something completely different, and we'll get to that. But data cleaning is something different, and the seed is for. So just we took a very easy problem to show you as an intro. Like if you want some table to be managed from your version control, like this was a good example, right, of managing a table from version control. You know for sure that this code has this language, and this is kind of like created by us. It's not being ingested or being sent by someone. So for that application, you have to do this. But for what you're saying, I would suggest don't do seed. Seed is not the way to go for cleaning up data.
We mostly stick to like data sets that are very small and doesn't change over change much in a period of time. And yeah, so that's the only reason why we sort of version control it. Like if it is any big files, and if we expect that the data is volatile and it might change, then it is suggested that not to bring it under seed. Like there are other ways to actually bring it into the data warehouse through DBT. That we'll come to it little later. Just one small disclaimer before we go to the next. You see, along with the language, there are other tables. Like as I said earlier, the scope of this discussion is only about transformation. We have sort of ingested some data already into landing. Those are raw data. We will show those, but just giving a heads up that we have some data in S3 we have already ingested into landing. We'll quickly show how raw is that data. But yeah, now let's come back to the question.
So automatically we get the schema without.
Yeah, I'll show you that. So I'll show what exactly happened when we ran this. So whatever we do, right, DBT will generate a set of queries and run. So I'll just show you the query history. This is like the logs of your Snowflake. It will show you what all has happened. So over here,
So you already have the table, so it translated.
yeah. So since DBT seed was already run, the table was already there, what it did was it truncated the table. So it did not create table. It truncated it, and then it did a wait, sorry, this is something I ran just now, and it inserted that table. So I did not have to write this query. This is something that DBT does. So DBT just compiles the code that we write. We usually write SQL code with. I just showed you CSV as a simple example. For seed we use CSV, but for actual models we use SQL. But this is what it does. It takes your code, it compiles it, and it runs it as a query. Yeah.
So there is inbuilt capability for Snowflake. It has this CSV, right?
So yeah.
And AWS in Redshift, like we can use push commands.
Mhm.
With that, if we can avoid like this all this long SQL from there. So what differs from that two types?
So the main aim of DBT seed is to version control, right? So if you can put CSV, you'll have to write extra code for your CI to pick that CSV and copy it or upload it directly using SQL. You have to create another SQL connection, write extra code to run that SQL or SQL to pick up your CSV and run it. DBT provides it within itself.
within that, it will, the version control will happen.
Yeah, version control in your repository.
Also, copy command is more for a scenario where you get data from external third party, and say your file will get dropped in a separate cloud storage. From there, you can use copy command to load the data into your.
Actually, we have used copy for ingesting data, but that's out of the scope, so we are not covering that. But for ingesting data and all, so we actually have all the data provided as CSV files in S3 bucket, but that's out of the scope. We're just focusing on the DBT part of it. But yeah, that is used for that. Any other questions around this?
Also, in this case, if you see, like, there was a truncate table before we actually inserted. So DBT is very intelligent enough that, say, in case if the table was actually not present, then it would actually create the table and then insert.
Let's
if it is not
show that.
present, yeah, you can show that. You can drop it. So if it is present already, it will make sure that it truncates and then do a full refresh.
So now
It will be always like clean flow, like it will not do updates.
depends on what
With
you're
seed,
running.
it is always update like it
With
will
seed
be.
it is. With models, which will show, but we'll not cover this, but it depends on what kind of this you're doing. Anyways, so here now the language is gone. I dropped it. Now if I run the same seed, we'll check the query history. It's still running. Let's wait for a couple of seconds. So in this case, you see, instead of truncating, it created a table because it did not exist, and then it inserted. I'm not opening and showing, but this explains it, right? So that is basically seed, and this was a very basic way of just an introduction to DBT and how DBT works.
Query history. Just one more thing to add here. So if you see one weird thing here, create table is outside a transaction block, whereas insert statement is between a transaction block and begin and commit. The main reason is like in this scenario, we just have one seed file, but we can still have multiple seed file. Like what DBT also does is DBT it sort of tries to identify whether if there are any dependency between the different seed files that we have. If there is no, then what it will do is it will try to do things parallelly, just to make sure that like things are transactional. By default, it sort of make this operation transactional.
One more question. So within the schema, these schemas and all the tables which we need to create in Snowflake and the configuration how to do, or the seeds, whatever the available in the seeds, right, it will take all the files.
So it's an inferred schema, like Snowflake by default infers the schema, then it just creates.
From this file within the.
No, this is the schema is from this you're talking about, right? The create. That is DBT creates that.
Yeah, inferred schema.
DBT infers
So
that.
the files, it will create the table of all the other setups, it will take care of it.
Yeah.
If I want to insert 1 billion rows, like how performance?
Again, I would suggest not to check in 1 billion rows in a version control. Like usually that application, I personally would suggest you not to do that. This is for a small data set, especially like languages, like we don't really have like highly
It's a conscious
defined.
choice that we have to make that.
Yeah.
What's the max size limit that we'll sort of version control in our repo before actually using it as a seed? Like if we feel that it's a large file, then there are other ways to actually ingest. You can just do a normal ingestion, like a copy command of sorts, where you can place it in a S3 or GCS bucket, and then you can load it into a.
This DBT is only for smaller.
Exactly.
No. The seed is only
Seed
for
is
small.
only for
Not DBT will show many other things. So
You said DBT seed can do multiple seed files, right?
yeah.
Should that be on the same template or
So
or can it infer the relationship?
it can infer. DBT can infer. So you can create one more file over here. Now there's language. I can create one more file saying movie genre or something like that, and it will infer based on the number of columns in the CSV file.
Can we say that DBT seed you can use it mostly for
No, it is for a well-defined, developer-defined kind of data set, a small data set, and that's why I took language as the example for this, because it something like different types of movies is not a good example, because every day a new movie is released and we can't really version control it. But language, see, again, as you said, it's a conscious choice. Language, every day a new language won't come, right? So you choose what it, and there are not so many languages of movies, like we don't have billions of languages of movies there, right? So that's the conscious choice. That's where you have to think like, oh, does it make sense to use this? So we covered seeding and we covered the related structure. Any questions so far? Or are we good? We'll proceed. So about DBT, the main reason is like your project structure is typically like a software engineer, how you would do. I again and again kept on repeating myself. It's like SRC, lib, test, and like so it maps to that, right? So it's models. Instead of lib, it is macro. So that you get a software project like repository. Now since you get that, you can check it in. Like you can just do git, add, commit. You can check it into your repository. You just need to know Jinja 2 and SQL. Like if you know that, you basically know DBT. There's nothing like that advanced about DBT. It's very easy for you to pick up. It's very developer friendly that way. Again, we'll be covering this, but you can run tests. You can actually write unit tests for your SQL files, which is otherwise kind of hard to do. Again, since it's a repository, after checking in, you can run CI/CD, you can run your tests, you can deploy your models, your code from that onto your data pipelines. And again, we'll also be covering, you can generate docs. Again, I'm not a huge fan of docs explaining code, but there's a very interesting feature which I'll show at the end. So yeah, we'll go and analyze some data that we have.
You quickly show how the raw data looks like in Snowflake.
So we have a landing schema in which all the ingested tables are coming. So I'll quickly show. Just ignore most of the tables over here. The main focus table for us is the metadata, movie metadata. So I'll just show how this table looks.
The segregation that you see here, landing and target schemas, it's a general data engineering practice where you sort of create a landing schema or raw schema that we call, where you just dump your data without any transformation, and that's why landing schema has all the raw data in it.
So this is how the data looks kind of. It's very raw. We have got a CSV file, it just got converted. As someone mentioned, copy, right? So the CSV file just got copied. And we have this structure, if the movie is an adult movie or not. If it belongs to a collection, like a movie can have sequels, so they can all be grouped into all the sequel movies, subsequent movies like part 1, part 2, part 3, they can be grouped into a collection. How much budget, this many dollars was spent in making of that movie. Genre. And there again, like what is the title on IMDb, what language. So I showed the seeding of language right now. If someone doesn't know what is EN, you can refer it from that table. Name of the movie, it's called original title. A brief overview. And there are a bunch of things. Don't need to go through all of that. Any questions around how this data looks? Something weird, something fishy? Sorry?
What is the source of this data?
I just pulled it from some Kaggle thing.
It's out there, open.
Yeah, it's out in the open. Any other questions? Cool. Yeah, so anyone has any favorite movies? What?
It was already there.
The one which was there. Anyone else? Any favorite movies? Let's just check for fun if it's there or not. Captain America. Is that the exact this? Yeah, and it also comes in a collection. So you can see it has some genre associated with it. Oh, there are different Captain Americas. Again, another interesting thing is that they are different ones. So what I'll do is I'll take the movie title, and I'll take the movie title and I'll take the release date just to check why they are different. So they are the different times Captain America was made. Anyways, 1944 would be crazy. Yeah, any other movie, anyone? Any favorite movies? What? Inception, nice. Good choice. Huh? It's not there. It's there, man. So let's again, like, I'll get. Yeah, so Inception we got. Anyone else? Anyone wants to find any details about the movies they like? Interstellar. Yeah, you are going for Christopher Nolan, man. I hope the spelling is correct. Yeah, we found that. Okay, so let's move on. We'll just check how many movies we have just for fun. We'll just play around with it. Let's check how many movies are there in the database. So we have around 45,463 rows. Roughly, this is how much we got from the data we ingested from the open. But let us try to check how many of those IDs are unique. Like, is it the same or is it different? This will tell us if there is any inconsistency or something fishy with the data, because ID, as we say, should be unique, right? And you see there's a difference in the number. It's not a huge difference, but it's at least around, I guess, roughly 30, difference of a 30, maybe? Yeah, so let's just go ahead. Okay, should we take a short break? Yeah, so everyone had a nice snacks break, so let's start off. So we were looking into the data, right, and we saw duplicates. That's where we stopped last. So we saw that some of the IDs are duplicate. So we'll just jump on to the next problem. So the problem is to remove the duplicate IDs. So here you see it's the same thing that we ran before, wherein you can see the actual rows in the one without doing distinct is slightly more, like around 30 more records are there. So let's try to remove that. So I'll introduce the next concept as I was showing you the directory structure, right? Like we showed you seeds, there's something called models. Now, as I said before, model stands for your source, your SRC. So for this, filtering duplicate data, we already have created something called unique movies. So what does this model do? Okay, so quick this, every model can be configured. You can specify what it can be materialized as. I won't delve too deep into what is materialization, we'll do that subsequently in the further slides. Database to which it should materialize to, so the output will go into that particular database. Again, materialize is table, so it will create a table in that database and in that schema. So movies.target. What will be the table name? The table name will be unique movies. What it is doing is from the source database, which is your movies metadata raw, on which we just did analysis, it will take that and it will select everything. But this will just select unique. So this query is Snowflake specific, where it selects unique, right? So any questions so far? So I'll just run this particular model. So to do that, in the CLI you do DBT run will run a model. You can specify what model you want to run. We specify. Now if we check in the database, in movies, in landing, ignore landing. our this would be target. So in target, that table is not there that we want. That is unique movies. So let's go ahead and run that unique movies and let's check if it's created. So when we run this, again DBT will pick this file up, it will do whatever it has to do, and it will run this. We'll again have a quick glance on how it looks. Still running. So in the query history now, you should see how it creates. So now it doesn't run a separate create and this. Here it creates it directly using create and replace transient, and it uses the same query through which it takes everything from the source, does the filtering, removes the duplicates, and it puts in the target. So that is what we will be having here now. So if I refresh this, we'll have this unique movies, and I hope this works. I don't know if this works or not. This time we are not selecting landing, we are selecting from target. Yeah, the 30 extra, these are gone, which from the source which were there. So we have removed duplicates. So that is how we have removed the duplicate data and we have run. So this is how DBT transforms data. So I think you asked where you do transformation. You do transformation within your Snowflake. So it's just that we have separated the the two layers. What is coming in is in your landing, and then whatever you transform and put, we have created a target layer. Any questions so far? Yeah. Yeah, I don't know, like distinct was not working when I was writing, so I just googled how you should do it in Snowflake. Snowflake supported that. Any?
So it's just a ranking operation to basically filter which is the latest one. Like nothing specific. You just do a distinct, then it by default picks the latest one. But this is just to do a ranking operation.
This is the model we use, right? That is generated by, how does that work?
So you're talking about the models that I showed in the code, this SQL file, right? This is what we write on our own. This model is not your ML model. It's
No, what is
yeah.
So that we have to create a model.
You have to write this code.
Yeah, I have to write that.
Hmm.
And that we can reuse it anytime.
Yeah. So what you can do is in your pipeline, right? You can write a scheduler and you can run it periodically, or you can run it on some trigger, like if data is ingested, run it. Any other questions? Cool. So we covered concept of models now. So you know what models are. We'll further delve into a little complicated models later. But I talked about SRC. I also talked about test. So what about testing? Like, can we actually test that, right? And I said that if it was not for DBT, maybe testing SQL would be a little complicated. So we also have a test directory over here, and for this we will have unique movies test. So let's just have a look at the test file first, how the test file looks and how readable it is. So we specify a tag, because it's a unit test, we have specified a tag to be unit test. And then what we are testing the unique movies model, which is this model. So we're telling what this, and we should generate, this is wrong, it should be unique movies. And we mock the source table, right? And in the source table, I've just created some, repeating IDs to emulate what would happen. And then in the expectation, I've just removed those. So this is how the output should be, right? So now we can run this test. Again, same CLI, DBT, test. We can select a specific test, unique. And I hope it runs. And it ran. So this is how you unit test. You can even test drive, and when we were working together in a data project, we actually were test driving the models that we were writing, and we can write different test cases like that. Any questions around
This is
this?
just, but it still runs in Snowflake. But the thing is, it doesn't actually create tables in Snowflake. Instead like it creates a temporary table like without actually like using the data storage, and then it does the testing on the runtime.
Yeah, let's. Should we show? I don't know about time.
So how the second one will be expectations. It sort of dynamically creates this query that is an expectation and actual, and then it tries to assert in the end
So,
actual and expectations.
Just out of interest, I will just show how it shows us the failure. Because for me, right, honestly, having tests is very important. Like, without which it's I don't get confidence in modifying the code. And till today, I never like. Not till today, but till I had not worked on DBT. I was not knowing that you could actually test SQL, and this is what it is. So now that I have removed one of the rows from our expectation and I ran the test, it shows a failure that that row is not there.
One more thing about this particular test framework is this test framework is not by natively supported by DBT. This is a test framework which is actually built by equal experts, and it's currently open source and it's been actively developed. And DBT open source community has also been actively asking people that like they can this particular equal expert unit testing framework that they can use.
So I'll just show that to you. So there's again a quick detour. There's something called packages. So it's like if you are using npm, there's package.json, or if you are using Java, you use Maven. To pull Maven Central, you pull it from. So similarly here also you can define your packages over here, and you can list down what packages you are using. So here we are using the DBT unit testing framework, which is like open source by equal experts. And that once you run DBT package, or I think it's DBT debs, I guess, the command, and it will install the package in your DBT packages directory. Right? Any questions around that? Yeah. Sorry?
Yes.
Yeah,
so
it is
It's
CSV.
not just tab separated. You can use CSV, and the
This
DBT
is-
can be anything. You can also use tab.
This is actually a CSV. When the testing framework picks this up, it picks it. It is nothing but a CSV. Two chunks of this is one chunk of CSV. This is another chunk of CSV. But instead of comma, it's a pipe. That's it.
Instead of CSV or TSV, you can also pass an SQL statement.
Yeah.
For a service.
But that just makes it hard to read. So I usually don't go ahead and do that. So yeah, so we covered unit testing. So it's one more concept covered. There's another test that you can write. It's called data test. Again, this does not run in the CI. It's called data quality test. So whenever something is ingested, you want to ensure you have to validate it. For example, like the best analogy that I can think of is from a software standpoint is form validation, right? You write an email and it's not in the right format. For that you do form validation before the user signs up. Similar, you can do in data as well. If some bad data is coming and we don't want that, we can write a data test. Again, we can write that in DBT, out of scope of today's talk, but if you want, we can discuss data after today's session.
So there's a saying in data like where never trust your data reason. Data from your vendor can go bad anytime. So what this data quality test sort of does is, so this unit testing that you say, like it runs on the code that you do, but data quality test is something after you perform the transformation using DBT model, you can configure your data quality test in the DBT project.yaml. What this test would do is, this test would actually run on the actual data in your warehouse. It will give you feedback whether there is any issues. Currently, we have not included the scope of this discussion, but I'm just putting that here. DBT does support data quality test.
Okay, moving on to more advanced things.
Yes. So let me put a problem statement here. So I'm a movie buff. I love watching movies. Like I'm into more science fiction movies, like where I handpick science fiction movies and then I try to watch. But there's always going to be multiple genres. One movie can belong to multiple genre, and one genre can have multiple movies. So if you imagine it as a table, it's a many to many mapping table. So yeah, let's try build a model for that.
Let's go to code.
Yes.
Which one should I open first?
So if you see here, we have created a model like which will do this movie to genre details. If you see here, line 13, you see something like enclosed in curly braces. This is what we call as Jinja templating, and this dynamically injects your schema name and database name. And the source keyword is basically it refers to a table or a data source which is outside your DBT project. For example, say the data that came into the landing schema, it's not inside the scope of this DBT project, but it's an external database. So by default, we say this is a source, and it doesn't have any. The DBT project doesn't have any information about it. But what we can do is for this, so it says that the database is movies, and the table name is movie metadata. So what we can do is in your DBT project, we can sort of create a source.yaml and then define what are the columns that you can open the sources. Not this one.
I guess you are renamed the schema data to schema data.
So it's the movie metadata. Movie metadata. Yeah, so if you see here, we have mentioned that there is a table called movie metadata, and its source is in database movies and schema is landing, and you will also specify that all the columns that belong to that external data. So now that we have specified a source, it is easy to access your columns inside your DBT model. Can you go back to the model? So now if you see this model is very straight enough, we are just accessing few information from the source database. And the line 14 that you see is more, if you remember the raw data that you see, it had a lot of JSON data in it. So it is basically, this part of code is just to flatten the data and have it as a
So someone was asking, right, how do we clean, like the cleaning steps? So this is one of the cleaning steps. So we get raw data, and the field within the column itself has like JSON, and JSON is not very database like relational database kind of structure friendly. So we do flattening, and this is how you do flattening, and you extract out the data from JSON. Yeah. Go ahead.
So yeah, this is the model. Now let's run this particular model.
Plus, no.
Let me create. And now if we go to Snowflake, we will see the table created there. Yeah, but again, if you see this particular table has only movie and genre. Let's say let's add another problem statement here. Let's say from a particular genre, I just want to watch movies. Let's say whose rating is more than probably 8 from again. So in that case, what we'll do is over this particular model, we'll create another model, and let's create a dependence. Can you open movie? Movie ratings. Yeah. So what we have done is, we have again accessed from a table called rating raw. Ignore line 5, it could have been again from the sources that but for now we have hard coded it. So in this case, what we are doing is we are using the movies by genre SQL, the file that we have created in line 9, and along with that we are sort of enriching with the rate information. Now let's go and create this. Now how this particular table will look is whatever columns that we have in the movies by genre table, Along with that, we're just going to have an extra column with the rating information. But now, if you think of that, it's just redundant data. Like both movies by genre also have the same columns, and movies by the movie rating also has the same column. So it doesn't make sense to sort of create the table twice, like with the same information. It's going to still occupy the space. So now what we will do is we will. It doesn't make sense to create another table with the same data. So we'll make the new table that we created as a view. Now we will quickly show how easy it's to actually move a materialization from table to view. So if you remember, there was always a config block on top of every model. Go to movie rating. Movie rating. Okay. It's very simple that in case if you wanted copy that particular block. It's very easy and straight enough. Whenever you want to create a table, the materialized value that you see, like there are multiple values. For now, you have seen table. Table, it basically sort of visualize your end output as a table in your data warehouse. Now, when it is view, what it will do is it will create, instead of a table, it will now go ahead and create a view. Now, let's run this.
Sorry, is it compiled?
Yes.
Okay. Thanks for telling.
Movie ratings. It's just movie ratings. Okay. I just updated
It's there. It's gone.
Yeah, now if you
So
see here, it has moved away from tables. And if you open views, you will see your movie rating view here. Should we also show the query history?
Yeah.
So as I said, like these are minor configuration changes, like which should let DBT know what operation it actually needs to perform. So let's say this is the movie by genre is a very huge table. If you do any operation over movie rating, it's going to be very costly. Since it's a view, it is going to every time do a join with rating, and then it is going to take a lot of time. So now what we will do is we'll make the movie by rating as a table, but make sure that, but since movie by rating already has all the information needed, we don't actually need the movie by genre. So what we will do is we'll move movie by genre as an intermediate table, so that it doesn't actually create as a table. We only have movie by genre in movie by rating in the final output. Can you go to that table?
Which one?
Yes. Just update materialize as table here. So I'm changing the movie ratings as a table. It's going to get visualized as table. And movie by genre, go to movie by genre. Update it as ephemeral. So we are introducing a new materialization called ephemeral now. To help understand what ephemeral is, in technical words, ephemeral is more like an intermediate table. But to help understand more, let me put a scenario in software engineering. Let's say there is a common method in, let's say there are 10 classes and there is a common method across all classes. And whenever there is a change happens, what you'll do, we'll go ahead and change it. So in that case, what we'll do, we'll basically abstract that particular common code out and then have it somewhere. Like ephemeral is something like that. Like let's say we don't need this, but let's say there's a huge model and there's some piece of code just to make more modular and readable. You can sort of abstract that code out as an ephemeral. When you abstract that out, the advantage is it doesn't get materialized as a table. You don't see that in the output. But the good thing is you can still unit test this particular piece of code and ensure that it is actually working. So now if we run, what will happen is the movie by genre table will disappear. It won't be there. But behind the scenes, it will create a temporary table, movie by genre. It will compute the movie ratings table, create it, and then it will drop the movie genre table again.
Also, when we run this, you see it will pick up.
Yeah. So if you see now, still movie ratings is happening. Now, as I said, movie rating model depends on movie by genre. So now what we will do is we will relate movie rating table with movie genre. Can you go to movie rating? Let's just update that. So now if you see here, earlier we were hard coding the movie by genre like with database schema and the table name we were hard coding, but now we have changed it as ref. What it means is it references to that movie by genre. Now you need not run movie by genre model. What you can do is you can just run movie ratings model. DBT will identify all its dependent model and it will run both the models together.
So you can check it over here.
So you see with underscore DBT CD, that is an intermediate table which doesn't get visualized as an end-to-end table, but internally it just uses that value to create the final movie rating table.
How many of you know CTE, concept of CTE? It's like subquery. Yeah. So it basically ephemeral model is nothing but a CTE. It converts into a CTE. Yeah.
What is the use of this ephemeral data?
So you can. So it's like a reusable block, but not like it is. You can think of it like something that's used by. So now something else is introduced, and you want this same thing to be used. It can reuse it. Also, SQL queries tend to get used, and it's when the query gets used, it's hard to write a unit test for it because you have to mock a bunch of things, and that's why if you take out a small part of it, you can easily test that small part.
As a big block of HTML, you can walk.
You can extract out.
Yeah.
Yeah. Yeah. Anything else?
Yeah, that's it. Let's go next. So we have already been talking about materialization. As materialization, we have discussed it's more about how we want to visualize your data in the end data values. Currently, we have seen materialization table, view, and ephemeral. There are also other couple of materializations which we haven't at least added as scope of this discussion, which are slightly advanced, but still the other materializations are incremental and materialized view. Probably I'll just give a quick brief on what incremental and materialized view is. Imagine, let's say, there's a huge data set. Let's say there's a 10 GB data in the final table, and let's say every day there is let's say 500 MB data comes in. In that case, it doesn't make sense to recreate the entire 10 GB data every day. So incremental is a materialized feature where you can incrementally append data to your final data rather than creating the entire table from scratch. So that's what incremental is. And the next thing is materialized view. Materialized view is very data warehouse specific feature, like whereas materialized view doesn't support in BigQuery, but it has supports in Snowflake and other things. This is again, imagine more like a table, but it's still a view. What it does is it sort of it creates a cache and then stores the information from the source table. But every now and then it sort of do a refresh from the source table and then it keeps the data up to date. So that this is just to keep the query cost in check. Materialized sort of helps.
So we'll delve into another concept of DBT. So let's take another problem. Let's say that we need to link we have IMDb IDs. So I'll just show you the table over here. We have IMDb IDs present with us. So I'll just do it over here itself. So if I run this, you will see there is something called IMDb ID. So IMDb, it's Internet Movie Database, and it has this ID corresponds to a link. And again, if you go ahead over here, there is something called TMDB as well. It's not there over here, I guess. Yeah. So there's IMDb ID, there's TMDB ID. So now what we want to do is we want to create something like a reusable function which does this string operation of converting this IMDb ID to actual URL. Now we did show you how to create reusable part of SQL using ephemeral models, but we can create reusable parts of the code by pulling out a small chunk of the SQL. Like it doesn't do any select or anything. It's a small chunk. So here I'll go ahead and introduce to you macros. So in DBT we have something called macros, and there's this thing called prefix link. Now this is very this runs on compile time, and this is very Jinja specific. So the code here is Jinja. So there is, if the type is IMDb, then convert the value that is sent to the macro to the IMDb link. If the type is TMDB, convert the sent value to TMDB link. And let's see who is using this.
As the structure itself specifies, you can imagine macro more like a functional method in any language. You can sort of add any logic into it and then like pass arguments and then generate outputs.
So there's a model which is using this. It's called movies in DBs, and there's no import needed like we need in other this. Whatever you put in your macros directory easily automatically gets imported. You just go ahead and use it. So given the IMDb link, you prefix it with the IMDb whatever this it is, and for TMDB ID, prefix it with TMDB link, and create a materialized table like that. So let's go ahead and run this. And now let us check what was the name, movies in DB. So I'll go ahead and open the sandbox, and I'll say select star from movies.target. In target you should see in the tables it should have come, so I'll just refresh and show you. Yeah, a lot of things have come because we ran a lot of things. So movies in DBs is there. So target dot movies in DBs. So I'll say where original title is, someone said Inception Interstellar. It's not there. I'll just pick what we get from there. Just pick up, let's say, Jumanji, and if I click the link of IMDb, it should correctly link to the IMDb list. The reason I think Interstellar and Inception was not there was because probably the ID was not in the database. Any questions around macros? That is how macros work in DBT. So yes, we covered another concept of DBT macros. Any questions so far? Everything good? Too much, too little? Yeah.
So use macro slide state. Yes, almost. The macros can use any part of it.
So macros is just what the word says, right? It just substitutes whatever is there. So instead of writing that every single place, you just extract it out. So it's just something that substitutes later. Any other questions? Yeah.
So we are almost done with the DBT part of it. Now imagine after your transformation is done, like your end data would be consumed by someone. It might be a visualization, it might be data scientist or data analyst. Just for this use case, what we actually done is we had a ML model which sort of runs over the model that we have created, and it will sort of create movie suggestion for users. We do have like ratings and reviews that every user has given. So with those data, we have already pre-built a data set using the ML model that we had. So we will just show the output how it looks.
This one, right? I'll remove this. No, you go ahead.
So what we had is this movie. We have created a table. This is from whatever data that we had. Can you run it? We haven't ran it yet. Just do a DBT run for everything.
So when you do DBT run, it runs all the models from your code.
For now, we have been running individual models.
Individual
So
models.
When you do a DBT run, it picks all the models from your models directly and it will run. If DBT finds that if two models are not dependent, then it will try to run things parallel.
Now it has ran, and if I do this now, it is
So now if you see this particular table, it says that this particular user ID had watched it from this movie, and like this is the rating for that movie that he has watched. So now with our model, what we have done is, again, model is completely out of scope of this discussion, but what that model gives output is like, let's say,
when he's referring to model, he's referring to the ML model, not the DBT model.
So what it does is, let's say this user ID 265908 had watched a list of movies from a different channel. So based on this, it will sort of curate its user-specific suggestion, and then it will basically do like we have run that ML model in a very small data set. Probably can just show how it is the final output.
This one?
Yes. Yeah. For here for this particular user ID. It says that what are the movies that he can potentially watch. Even you can on the watch history you can filter by this user ID. User ID equals 650. So this particular user had watched these movies, like it's more around animated movies and few action blocks. So now his suggestion also would be around on the same lines, the movie suggestion. Any other movie suggestion? This is just to show how your end data after transformation would be used. This is just one scenario. There might be other scenarios where it will be used for visualization purpose, or where your data would be exported to a different vendor for some other use case. There are I would say a number of scenarios on how your actual transform data can be used.
This table is suggestion or what is it?
This one is this is suggestion. This is enhanced data from the model generated from the ML model.
Yeah. So this user would like to watch these movies based on like. Yeah. Again, it's.
Which underlying algorithm or model is used to?
I just pulled some script and I did it. I think it used SVD algorithm. Again, I'm not a ML guy, so but I think it used SVD algorithm to pull the data and yeah. Yeah. But it's okay. Yeah. So yeah, we can write complex flows. The thing with writing complex flows in DBT is that you can easily lose track of where what model is there, what model is using what now. Praveen told you, oh, this model is referring that and that is referring, and then further it's referring to some source, right? Then it's hard to keep track, and that is where we get to generating documentation.
Over a period of time, what happens is you lost track of your data source, or what will happen is your source data can version from version 1 to multiple versions, and you really lost track of how your past data was actually flowing through. So in data engineering, data lineage is something more important to understand how your data is flowing from source to the target. So not many tools sort of provide this. Let's take Spark. And Spark doesn't give this natively to have this DAG lineage of how data flows from one data set to another. But this is something very DBT specific, where DBT sort of provides that lineage, which by itself acts as a documentation. Not as an engineers, we always, at least personally, it's my personal opinion, I don't write documentation saying this data set is going to be used by this reason, and also we tend to miss to update over a period of time. But what this DBT docs it does is it sort of creates a documentation runtime just by looking at the models. Let's run this.
Before we do that, if you're using PyCharm or any JetBrains ID, there is something called DBT over here.
This is a new feature that has been rolled out in the last week by IntelliJ.
Where is it gone now?
One other thing. So documents are so Databricks platform. So they also provide, Databricks, not more than so, but it's deeply integrated with Azure, and they are providing something like ADF or something.
Again, I'm not sure whether how it's with Spark 3. I've been with Spark 2, like where I had scenarios, let's say, the source data comes in, over a period of time, the transformed or aggregated that we generate, like sort of transition to different versions. So the final output, let's say, at one point in time it might be from version 4, or at one point in time it might be from version. So those sort of like we can't identify from which source this particular data was actually created. That challenge I have seen in Spark, but I'm not sure how it has evolved in Spark. There might be some like something that's present now to help that, but
Yeah. So getting back, I was actually searching for that button here but I increased the zoom level, so I can't really find it. So you can just go on the model that you are on, and just you can click on this side. There should be a DBT this, which will show you lineage, right? So I'm doing it this way, and it points out the model which you opened. So it is pointing to this, and it shows the whole lineage within your ID. But let's say you're not using any JetBrains ID. What you can do is you can run DBT doc, generate docs. Sorry, docs generate. So this will generate documentation into like in a HTML file and in a HTML directory, like that can be viewed on a browser, and then you can serve it. So it's generating, and it generated, and then you can just serve it over a server.
so it's hosted locally so that you can go and see the lineage.
Yeah, so when you serve, it will start a server, it will open it, and you can just click this, view the lineage graph, and you can see the same lineage. This you can use if you're not using.
Now here, the all
JetBrains.
green ones actually point to the source. These are data sets which come from outside your DBT project. And if you hover, let's say you hover over links underscore raw, and you hover over one of the green ones.
Right. Yeah.
Yeah. So if you click it, it clearly says how your data is actually being like transforming from one model to model. Like
It shows the path of what your data travels, what path your data travels. You can just select anything, and it will just show what path it travels or paths it can travel. So yeah, that's quite good. Any questions so far? I'll cover that in one of the next slides. But usually DBT is meant to be run from your data pipelines. So usually I keep saying usually it's Airflow. So you'll deploy DBT.
any orchestration tool that
Yeah.
that you can run.
Orchestration tool. So it will. Sorry.
I'm not sure whether Glue is. I'm not sure whether it can be done through Glue, but always done from an orchestration tool like Airflow or Tax.
What does Glue do?
Glue is more like crawling data from a data lake.
So with the Airflow we can.
Yes.
Yeah. So Airflow, or there's something else also called Texter. There are many orchestration tools like that. So yeah, we checked how to look at the lineage. And to answer your question, this is how the flow works. So you have something on your local repository. You write your code, you make changes, you test it, you push it into your remote repository, wherein it can be GitHub or whatever. Then it will trigger a CI. Then if all the tests passes, like the DBT test that I showed at, if all the tests pass, it can go ahead, depending on how you write your CI, it can go ahead and do a CD as well, wherein it will deploy. And the deployment will usually happen onto a data pipeline, which can be something like Airflow.
Also, how the packaging works for data models is like you sort of copy your data models directly into any of the say GCS or S3. You deploy it to there, And actually, when running the DBT model from Airflow, you download back your actual code from GCS into Airflow, and then from there Airflow will sort of. Currently, there is no direct way of say DBT to pick up your data project from GCS or anything. Currently, that feature isn't there. So you have to manually download it back to wherever you run it and test it.
Okay, so if you are using plain data, right, it's something, it's like we are using plain data. So that connection is like how that, see, if we want to set of data which is already built, then the method which you mentioned, like, so we can expect amount of that here. But if we are working on the lake data, so that means we schedule.
Yes, exactly. Yes. So we will schedule it in such a way that how frequent you want your models to run, your models will be running.
That perhaps macro level.
Any other questions?
What about macros? Can I write unit test for that?
You can't just run unit test on the macros alone. You can probably create a model out of it and then you can test it.
Directly on macros, there's no. Maybe you can invent another framework. I don't know. Yep, so covered how the project architecture is, the deployment, and this. So I guess that's it for today. Any more questions? Anything you want to discuss? We are open for that. Yeah. The models are the things that do your transformation. The models are the transformers basically. If you want to visualize it that way.
So in the DBT has a clear way of naming and structuring, right?
What do you mean naming and structuring?
Starting with the role of the project, the folder, the naming of
Yeah. It creates a directory structure.
Is it the same thing in all the data model, like this model is the same thing in Spark?
I have not worked with Spark.
Sorry, I didn't get the question.
The DBT has a clear way of naming things, right?
Yeah, I'll just repeat your question so the mic picks it up. So what he's saying is DBT is an open-ended way of structuring your directory. You just do edit and it creates the directory, right? How is it in all of the data world? Is it the same as DBT or how different is it in Spark?
And not just the folder structuring, but rather the terms like model.
Models, yeah.
So I've worked with Spark apart from DBT. But in Spark, at least when I worked, there was no common common practice where like say there's a project structure, but we still try to be very similar to what we practice in software engineering. There are not many folks sort of do unit testing in Spark, but even in Spark you can sort of do unit testing. So with keeping that in mind, we sort of at least try to be very in line with what we do in software.
And does it have models or it's called
So
something
it is not
else?
models. There it's called jobs.
Yeah.
DBT is focused on which languages? Majorly SQL or any other?
It's SQL.
It's purely SQL.
Purely SQL.
SQL and Jinja 2 templated. Jinja 2 it uses and there is templating.
There is not AML, YML, so it is nothing but macro. Show that we show stuff.
Sorry, what are you?
Configurations? Look, configurations like we
Yeah.
define it in YAML,
Okay.
which SQL, like at least DBT will infer it from there. Like those are DBT internal functionalities where it will go through the YAML and then like bring in the sources into the actual DBT code that we write. There is one more question offline, like how DBT is being managed. So like what we use here is called DBT code. This is the open source package. But there is also an enterprise version of DBT called DBT Cloud, which is very similar to what for Spark you have Databricks or something like that, which is an enterprise version, which has some more functionalities, which provides a cloud IDE with a lot more functionalities in it. But what we use here is DBT code.
Can you briefly talk the history of DBT, like you said about that? Since what DBT invented to fix a particular problem, let's say in Spark, and that in itself became.
I think the reason DBT, I don't know about the history, but the reason people adopted DBT to such an extent is switch from ETL to ELT, right? Like you should not have to. So when you do ETL, right? You load while loading, if you're transforming, what happens is you have to think of compute time and all of those issues. With DBT, what you do is you just load data as it is, because you're doing ELT, you're loading everything as it is, and then you think of transforming. So that is what DBT facilitates. So now you don't have to worry about how to improve the performance of this code. Rather, what you can do is the DBT models that you write, the SQL queries, you can check whatever data warehouse. So for example, if it's Snowflake, you can check in Snowflake the query performance, and if it is taking too much time, or if it's very expensive query to run, you can try to optimize it. So it's a different way of doing, and I think a lot of people liked this, and that's how DBT was picked up, like, to do. I think Spark.
So DBT, as I said, comes under ELT. Before that, it was mostly ETL. And minor downside of ETL is like ETL can work well with typically small data sets, I would say. But when the data set sort of grows, like it becomes a bit hard in terms of compute and managing resources. That is when the data warehouses came in picture, where you can sort of dump whatever data that you have in, say, data warehouse, and from there you can start doing transformation. So when data warehouses started blooming, there was a big space for some tool to actually like leverage the compute resource and performance of data warehouse. So that's when DBT came in picture. So that the main difference between Spark and DBT is that you need not worry about your compute. Like everything is managed by the data warehouse. Whereas in Spark, like you have to manage your compute, like configure your Spark job, make it efficient. It's a very tiresome job in Spark, at least. When I in Spark 2, that was the case. Spark 3 has evolved, but still, since I've come from a Spark background to DBT, I felt DBT a lot more better than Spark. But again, it differs from use case to use case. There are still some use cases where Spark is better. For example, when you do complex transformation or some sort of NumPy operations or scikit-learn operations, like those sort of places, Spark is still better. Those you can do it here. But here, when you want to do more around data exploration and like complex transformation with huge amount of data, that's when data warehouse and DBT comes in.
And we say DBT boost takes care of the transformation part of the life.
Yes, DBT is just for the transformation, doesn't do anything.
And Spark is actually a framework.
Yes.
Any other questions? Yeah. So you can actually run it, as we are talking, right, we already mentioned, you can run it from an orchestrator like Airflow. And Airflow can, I don't know how well this is set up, but if it is set up,
if you want to run in an ideal environment, what I suggest is you can run from Airflow. You can also
I don't have it running right now.
Airflow and then run there locally. But still, that is not suggested way. Reason, it's not the job of Airflow to actually have the code inits directly and then so. At least the way that we practice in production is like we sort of create a separate container which will run DBT. So whenever we want to run a model, we just pass in the arguments. That particular container will run in Kubernetes. It will download the DBT code into there, and then that Docker container will actually run the DBT model. So Airflow or any orchestration tool's role is just to orchestrate and not do anything else.
Yes, discuss real world something that you actually use DBT for in production for state compliance.
Yes, sure. So in my current gig that I'm doing, so the entire operational database, it sort of sits in a Postgres database. It's a very huge database. But since it's very transactional and it's like the data sort of keeps changing, what we do is we sort of have Debezium over Debezium is a CDC job, which sort of sends the change data catalog and then moves the data into our BigQuery. So now this Postgres is just one data source. Like we have data sources like we include data from Jira, we include data from, there is something called Lever is very similar to an HR tool, and similarly from multiple different places where you bring your data into your warehouse. So now you have all this data. Again, this is just raw data. So this is where use DBT to perform transformation, like based on the business needs, you sort of do transformation.
Any other questions? I'll check if I can quickly show you how it runs in Airflow. Any questions?
Local Airflow running.
Yeah, we have a local Airflow. Docker is not running. Yeah. We don't have
Just
one.
open the documentation.
Which?
Just open the documentation. DBT.
Okay.
In the Chrome.
Which in our code.
We don't have any code. Probably I'll just quickly show how it's done.
Data quality. Actually, I also personally like, so of course there's no like unit tests also you have to do, but data quality checks is something that I actually like doing for this. And it's just like running DBT tests, but instead of unit tests, you create two types of tests. One is your unit test, one is your data quality test. And within the orchestrator, like depends, like if you like ingest you want to run or you want to run on a schedule, you can choose that.
So this is what you do. Like you remember there was this DBT project.yaml, which is the configuration file. There you will still specify what are the models that you are creating. So in this case, under models you see this name orders. This is the actual model, and it has this column called order rate. So it's very easy to write data quality tests in DBT, where you can just add a test key in your YAML and mention. There are lot many options available by default, but in this case, if you see here, it's unique and not null. So what it does is, in the orders table, on the order ID column, it's specific. It goes and after the data is transformed, it goes and check whether order ID column is unique and there is no null values present in that. If it is present, then the pipeline would fail and give us quick feedback saying that there is a data quality issue that has been introduced by the new transformation.
This is just like validation. You can actually write your own SQL.
So you can also write custom data quality, instead of the predefined data quality metric, you can also write your custom.
The pipeline will fail.
So you do a DBT run. DBT run would transform your data into your desired schema or database. Once that is done, you would run a DBT test after that. DBT test would be a stage after DBT run. Now it will give you a quick feedback whether the transformation that has happened earlier is actually good or not.
You can also do various.
Do it in multiple places. One is you can do it after transformation from the transformed data, or do it before transformation by pointing in the raw data.
And
so
you
with
can
raw
do,
data, you can ensure that if an issue is there, you need not even load it into your actual tables.
and you can do some additional things like you can like throw an alert, like you can alert on your Slack or something if your data quality tests are failing. So you can take an action. Oh, the data is not good. Maybe reach out to the whoever is sending you the data and like.
I was curious about is it possible to do something like I don't want it to fail. I just want it to perform filter.
You can do that.
Satisfies only source.
Yeah, but if like filter, it again sounds like transformation to me, right? It's not really test. It will filter. It will get the good data which I showed, like, and it will do that. And this is how roughly I'm just showing you how it looks in Airflow. So Airflow here it runs DBT seed, and this is sorry.
You said that this quality check can be done even with raw data. Because raw data, since we don't fully control, like I don't know where we're taking. So multiple times we would expect it to fail, and multiple times we would we should intervene and do something.
Not always. See, it depends, right? It depends on your data. Now let's say your data is something like movies, it really doesn't matter. But if your data is, let's say, transactions from a bank, and the transaction has some weird alphanumeric value or something instead of a number, that is when it actually matters. So it again boils down to what data is coming in. You can see DBT series running. It just shows logs over here. This can run on something in production. I'm just showing in local. I don't run a Docker this. But yeah, it can run on a schedule. This particular tag will have some schedule associated with it. It shows when it ran, like yesterday, like that. So yeah, this is what it is. Any more questions? Are we good? Cool. If there's nothing, we'll stop. Yeah. Thanks a lot. Thank you for coming. Thank you for listening.